let's do some more limits. All right, so here's the next limit here. This is the limit of x cubed minus y cubed over x minus y as xy approaches 0, 0. So again, when I plug in the 0, 0 for my x and my y, that's always what I check first. I get 0 over 0. So I have to figure out where I'm going to go from there now. Because when I look at this, what other algebra tricks do I have? Another algebra trick we can use is factoring. And actually the top factors, believe it or not, that's the difference of cubes. Google that if you forgot the formula. You may have known at one point, but not anymore. So let's take a crack at this one now. So if you forgot, x cubed minus y cubed is going to factor into x minus y times x squared, and this is going to be a plus here, a times b, and that's going to be xy, and then it's going to be plus y squared. And that's just from the formula. And on the bottom, it's just going to be x minus y. Now, notice what happens when I factored here. If I take that whole bottom, it's going to cancel with one of the factors on the top, kind of like the square root one did earlier. So then this is actually going to equal the limit of xy as it approaches 0, 0 of now x squared plus xy plus y squared. And when I plug in my 0, 0 here, because it's a polynomial, it's going to be continuous on r squared. So this is going to give me 0, which is a good number. 0 is a good number. It's a real number. That's why it's a good number. Okay, so anyways, let's talk about the next one now. So the next one's a little different here. At first glance, you want to try some stuff and say, oh, this is tough. Nothing's working here. There's a lot of things we can't do here. I can't split it across multiplication. I could try to pull a y out on the top here, but I still have a plus y squared on the bottom that isn't going to go anywhere. So the idea of splitting it up to get a multiplication isn't going to work. So I'm going to have to get a little more fancy with this one. Come to find out, this one actually doesn't exist. And I know that because I'm used to seeing these types. These are one of the more fancy types. So you could try a few things, and if you can't get anywhere and it looks complicated enough, you might say, let me see if I can find some paths. And maybe I can find one that doesn't work. All right, so there is one here that we can try. We can say, hey, let x equal 0. And think about what that means three-dimensionally. So if this is my xyz, if x is 0, then let's think about where I'll be. That means I'm not going forwards or backwards. That means I'm going to be right on this line. So that means wherever my function lives, it could be up here somewhere. I'm going to take that line where it's y. I'll project it up there, and I'll say, hey, I'm going to take that path. And then we'll see what happens at the point of interest. See if it's going to be continuous. And if I get something there, let's say I get a finite number there, and then I pick a different path. Let's say, hey, I want to pick a parabola or something weird. I can pick a parabola, and I'll pick a path there. So that's going to look like this on my surface. Ooh, that looks cool, right? And then I could say, oh, once I projected that up, then I can see that, oh, that gave me a different number. And if I take two different paths, and they give me different numbers, that tells me they don't match up to be the same. So just like in 2 dimensions, if my left side of the line doesn't agree with the right side of the line, then I say the limit does not exist because those have to be the same. So any path I take would have to give me the same number if the limit's going to exist at that point. So that's what we're going to try now. We're going to just try some different paths. And just think, I just picked a weird path, right? A parabola. Now, the other thing to be careful of is whatever path I choose, make sure that goes through 0, 0. Okay, because I could pick a line like over here. Now, 0, 0 is way over here, so there's no way that line's going to help me in any way because I'm not even talking about the point 0, 0 anymore. So the most important thing is the path I pick, make sure it goes through 0, 0 for this one. Now, it could be different values later on, so kind of keep that in mind. So let's say my AB was over here somewhere. Let's say it was right here. So that would be -1, +1 on the x and y. Did I do that right? Yeah, -1, +1. Yep, I did. Okay, so if I'm back there, if I pick a path, I'm not going to pick the y-axis because it's way back there. It's not even going to touch my point. So that path isn't going to go through the point. So just make sure that's an important thing to consider when you're using this technique here, because they're not always going to be through the origin. So it's like, oh, it's harder to pick a point. So this x equals 0 is, though, right? That x equals 0 means that my limit then is going to now just be y, because I'm picking a certain value. My y is going to approach 0, and that's going to give me my x is 0. I'm just going to plug everything in because I want you to see this. And that's 0 to the 4th plus y squared. And then I'm going to clean this up a little bit. So my limit is y approaches 0. Because remember, my x is 0 here, and I'm on the y-axis. Then that's going to be 0 over y squared, which this is the limit as y goes to 0 of 0. And remember that rule, when it's a constant, when it's a constant, that means it's just going to be the constant, so it'll be 0. So that's my limit when x equals 0. Now let's try a different path. Another one I can pick is y equals x squared. That goes through 0, 0, because when I plug in 0 for x, I get 0 for y. So that confirms that it goes through 0, 0, and that's what I need. X squared. I'm picking a parabola here. And I picked this on purpose. I knew it was going to work. So let me take a look at this now. So the limit as xy goes to 0, 0 here, this is going to give me x squared from the first piece up top, and that's up here. And then I get a y, so I'm going to have another x squared up there. And then on the bottom, I'm going to have this x to the 4th. And then now my y is going to be x squared squared. So now when I clean this up a little bit algebraically here, this is going to be the limit of x comma y as it approaches 0, 0. This is going to be x to the 4th on top over x to the 4th plus x to the 4th. Now that's what made me pick x squared, because when I look at the original here, this was x to the 4th, and what would make that easy to add with that y there? So if I picked an x squared, I'm squaring it, so that's going to give me an x to the 4th. So that's the reason why I picked the x squared, believe it or not, because when I see that, I want those to be the same powers, because if these are the same powers, then I can add them. And that's what I was looking for here, just so you know. That's one of those things I look for. So this is the limit of xy as I go to 0, 0 here. And this is really going to be x to the 4th. And what happened on top was just a bonus, 2x to the 4th, because now these are the same, so they cancel. So I actually get the limit of x comma y as it approaches 0, 0 of 1/2, and that equals 1/2. Now notice this. These here are different values, which tells me no matter what path I pick, as long as I'm going through 0, 0, should result in the same z value here, and this one doesn't. So since that's true, since this doesn't approach the same value, this would tell me, it would imply the limit of xy as it goes through 0, 0 of x squared y over x squared, oh, not x squared, x to the 4th plus y squared does not exist. So there's my answer for this one. Because I checked two paths, they both went through the same point, and that was the point of interest. Therefore, and they gave me different values, therefore, it does not exist.